a request to go over some kinematics questions. Here I have a problem roughly in the level 6-7 questions, and these are posted on ManageBack already, so you can have access to these. The answer key, I believe, is also posted on ManageBack as well. I'm not going to go over problem 1, but over question 2. This question is a little bit it's quite challenging. You may also notice that I've labeled the 5 steps to problem solving. Number 1, drawing a picture. 2, defining your knowns and unknowns. 3, writing down the applicable formulae. 4, solving the question. And number 5, checking your solution, evaluating it, whether it makes sense or not. I'm going to model that in this problem, and we'll go over it together. Number 1, we're going to draw a picture where we need to make sense of the question. In a historical movie, 2 knights on horseback start from rest, 88 meters apart, and ride directly towards each other to battle. So if I want to draw this one out, I can draw a line between my 2 knights. This is 88 meters of separation. One knight, his name is Sir George. Sir George, okay, that's Sir George. He has acceleration of a magnitude of 0.300 meters per second squared. So he's going to charge this way. Sir Alfred, he's going to start on this side, and he's going to charge in this direction, opposite to that of George. They're going to collide. Well, let's see. So they're going to collide somewhere in the middle. So let's say that these 2 collide somewhere here. That's where they collide. Sir Alfred has an acceleration of magnitude of, so I'm going to label this one A, I'm going to label this one G with the right color. This one is 0.2 meters per second squared. What I've done is I ran kind of a motion in my head of roughly what's happening. This is really useful for you because in kinematics, you're solving motion questions. If you don't know what's happening, you do not know where to start. Okay, start off with a picture, run a video, do whatever you have to do to make sense of the question. I've already started labeling some of my knowns and unknowns, which is step number 2. I have the distance, 88 meters. I also want to find where they collide. If I want to do that, I'm going to label relative to Sir George's starting point. So from here all the way to here, I'm going to label this distance as x. The interesting thing of when you have a question that kind of looks like this, you can also label the rest of the distance. So this distance over here, the difference between 88 meters and x, this one is the distance that Sir Alfred has traveled. So this one is the distance that Sir George travels, S of G, and this one is S of A. What else do we know? Let's see, they start from rest. Okay, that's an important piece of information. We know that Sir Alfred, VI, Alfred, he starts from rest, as well as Sir George also starts off at rest. Okay, I've labeled my knowns and my unknowns. I also do know that there is some time that they will take to crash into each other. I'm going to label George's time as TG, and I'm going to label Alfred's time as TA. Well, for them to crash into each other, TG and TA are in fact the same, which I'm just going to say this is equal to T. The time it takes for them to crash into each other is the same for them to travel this distance. Usually you will label your directions in a question. For this one, I am not going to do that because it's going to confuse you and it's going to complicate things a little bit. So I'm just going to leave it as is. Usually you would need to label your directions, whether that's in the forward direction is positive or backwards is positive, whichever that may be. Okay, that part is important for you to do for your other questions. So we've done this step, number 2. We're going to do number 3. In number 3, we need to identify the correct physics concepts. We know that acceleration is constant for both George and Alfred. We have uniform acceleration. If we take a look at our formulae, the formula that contains initial velocity, time, and distance, you might be looking at this one. S is equal to VI times T plus 1/2 AT squared. I use VI now because many of you are confused with the symbols. But let's take a look at VI. VI for both Sir George and Sir Alfred is 0, which means this term is 0, and we will be left with S is equal to 1/2 AT squared. There you go. So that's the formula that we will use. Okay, number 3 is done. We've identified our formula. Number 4, we're going to solve the question, and we're going to box our final answer. What we know is that the T for Sir Alfred and Sir George is the same. Let's see if we can write an equation using the one we found above to represent each of these characters. So for Sir George, his SG is equal to X, which we labeled up here. This is the distance that he travels. This one is equal to 1/2 his acceleration times t squared. Since the time is the same for both characters, I'm just going to write t. The distance traveled by Sir Alfred, this is equal to 88 meters minus, and this one is equal to 1/2 a acceleration of Sir Alfred times t squared. We have two equations, we have two unknowns, and they are the same. That means if we do a substitution, we will be able to solve this question. Since we need to solve for the distance, we want the point at which knights collide, we need to solve for x. Because we are solving for x, I'm going to substitute t into the other equation. So I'm going to solve for t, then substitute into this equation, into the other equation. I'm going to start with Sir George because his equation looks a lot simpler. I have x is equal to 1/2 ag t squared. To solve for t, algebraically, I'm going to move 1/2 a to the other side of the equation. Okay, so I'm going to do that, which then leaves me with 2x divided by a is equal to t squared. Next, I take the square root of both sides. This leaves me with t is equal to the square root of 2x over ag. Now I'm going to take time and I'm going to substitute it into Sir Alfred's equation over here. Sir Alfred has 88 meters minus x. This is equal to 1/2 his acceleration times t. And now that's where I'm going to plug in this t value over here, which is square root of 2x divided by the acceleration of George in brackets squared. Since we're squaring and taking the square root, these two kind of cancel out. Simplifying this equation, I have 88 minus x is equal to 1/2 a for Alfred times 2x divided by a for George. Here we have 2 up here and we have 2 down over here. These two cancel out, so my equation can be further simplified. I now have 88 minus x. I'm getting lazier over time with my symbols. I have a at the top, Alfred's acceleration, divided by George's acceleration times x. Now, I will need to wind up the x's together. I need to solve for x. At this step, I need to solve for x. And to do that, we'll have to put the x's together. Put the x's together, I'm going to move this x to the other side. After I move this to the other side, I'll have 88. This is equal to acceleration of Alfred over acceleration of George times x plus x equals to 88. This part here, some of you might get stuck. What if we put some brackets around my two terms? Imagine in front of this x, I have an imaginary 1 coefficient, and I'm going to move the x's to the other side. I'm factoring out x. After I factor out x, I have 88 is equal to x in brackets, acceleration of Alfred over acceleration of George plus 1. The last thing I'll need to do now is to divide both sides by Alfred's acceleration divided by George's acceleration plus 1, and same thing on this other side. This leaves me with x is equal to 88 divided by a of Alfred, a of George, plus 1. Substituting our values, finally, we have 88 divided by, if we go back, Alfred has an acceleration of 0.2, George has 0.3. Alfred was 0.2, George was 0.3, plus 1. This one will give us, if I turn this one on, we have 0.2 divided by 0.3 plus 1. Notice this is at the bottom. I will do then 88 divided by, 88 divided by my answer, and I will get 52.8 meters from George. Whew, that was a long question. You could have also done this by putting this in your graphing calculator using the function that I've shown you before. What we do need to do at the very end of this question is to make sure we do step 5. We've solved the question. Many of you want to move on because you're happy you've solved it, but check your answer at the very end. Does your answer make sense? Look at your units. Check if you have your units. Does your direction make sense? My value also seems to make sense as well, because if George has a larger acceleration, the distance away from George at which they collide is probably going to be greater. So, does my final value answer my question? Yes, I've answered my question. And check your significant figures. I have 3 significant figures in my answer. I have 3 significant figures in all the numbers used in my question. So, all of these are checks. Saves you a lot of work, especially if you made a mistake. Make that final check is very important as well. And there we have it. This was a tougher kinematics question. If you have any other questions you want me to go over, shoot me an email. Otherwise, happy physicsing.